Hi, good afternoon, everybody. Thank you for joining the webinar. My name is Michael. I'm actually based in Singapore. I'm actually the product manager for safety, respiratory, and protection, which covers on air purifying respirators as well. So for today, we will be actually touching on the topic on disposable masks, or you might know it as filtering face piece, or we call it short form as FFP. One of the key topics that we're going to touch on today is also to select and also to understand the different standards that's being used across the world. So we rush through the agenda. We'll touch a little bit on the basic principles. Then we'll talk about standards across ASEAN especially. And we'll follow about how filtering face piece of FFP works itself and some of the legal frameworks within the region. And lastly, I'll touch a little bit on the fit testing and how to choose the appropriate filtering face piece. So basic principles itself. So it's of very general rule that for every breath you take in inhalation, you will take in around 4% of oxygen. That's going to be used up and transferred to energy, and we're going to breathe out exhalations on carbon dioxide. While intaking the air itself, there will be a lot of chances that you'll be breathing other contaminants in the air other than the inert gases that we shown over here. So some of the contaminants, we call this, will be most likely mist, dust, fumes, and at the same time unknown gases like contaminant gases, which is like sulfur dioxide or even vapor gases might be occurs as well. But however, for filtering face pieces, we will be covering how it protects us against mist, dust, and fumes. So before I really go into deep dive on the filtering face pieces, I'd just like to highlight a little bit on dust, mist, and fumes and what they are actually about. So for dust, it is actually a common term for tiny solid particles, which are spread through the air, which is also known as airborne particles. These particles are usually less than 5 micrometers in diameter. And if they are be classified as fine dust and which can be inhaled into lungs. And again, these microparticles will be further classified into two different groups, primary and secondary fine dust. Primary fine dust will be released directly from the source, which example through the process of combustion, fire. However, if the particles are formed by gaseous precursor substances such as sulfur oxide, nitric oxide, or ammonia, they are called as a secondary fine dust. The respiratory protection is needed during tasks which heavy concentration of dust are being produced, such as grinding, sweeping, or drilling. So respiratory masks against silica dust or the dangerous substance asbestos to prevent the inhaled this type of dust during working or during in the contaminated environment. Next, we'll touch a little bit about fumes. Fumes and smoke is actually an aerosol that is dispersed in microscopic form and it consists of exhaust gases, dust particles, and droplets of water vapor. So fumes and smoke is not just dust itself, but also consists of various particles. So the exhaust gases from the industrial plants are usually what we call flue gases. This deadly smoke poisoning can occur in apartments like permanent fires or even through acid gases in unventilated rooms. Now, of course, last but not least is actually the mist, which we know as liquid aerosols. This refers to the heterogeneous mixture in which the microscopic liquid droplets are being dispersed in gas. So one example is the Wobbler droplets in air. These substances are actually usually mixed with one another, individual components, which can be distinguished by naked eyes. So actually, if you look at spray cans itself, you can actually see the mist spraying out. Different areas of the mixtures have different properties. Of course, different in color, hardness, and even aggressive acids. These aerosols become hazardous to health when the particles are inhaled deep into the lung. Even disposable spray cans with flammable and highly flammable content can be problematic in the workplace. Other examples are included like oil mist from cutting and grinding. So you need to choose the right type of respirators to ensure that you are protecting against this type of mist. So before we start, we need to look into general requirements for using the APR. We need to understand that there has to be a minimum O2 present or oxygen present in the environment. So take our region example, ASEAN, we will be followed by the 19.5% rule. So you also need to know what type of contaminant and concentration, especially the concentration of the dust in the environment. And most importantly as well, is you are not allowed to use these products, especially filtering face paste, in poor ventilated areas or, most important, confined space. So before I step further on, due to the recent situation, we know that there's a lot of people asking what is actually a disposable respirator or FFP and surgical mask. What are their real differences itself between both of them? So for FFP or disposable respirator, its aim is to reduce the wearer risk exposure to certain airborne particles. That means you are protected when you inhale the air around you. But for surgical mask itself, we are actually looking at to assist to prevent the particles expelled from the wearer. So it's very crucial if you are, as an example, you're located in the hospital environment, the doctors and nurses have to wear surgical masks because it actually prevents the water droplets from spreading out to the community. The respirator itself fits tightly to the face and creates a seal between the face so that it ensures all air being breathed in is being filtered. Whereas the surgical mask is on the opposite, it's loosely fitted to ensure comfort, but at the same time it's protecting the environment more really than the wearer itself. So the lastly is actually for disposable respirator, it has to be put on and taken off from a clean area and wear at all times when you are in the contaminated area. So for example, if you are in hospital frontline, you have to wear this at all times and you can only take off at the clean and non-contaminated area. So for surgical masks, it's typically wear for a very short duration on a specific procedure. And example for in hospital cases, every after single use, you have to dispose the surgical mask and change to a new one with every different patient. So next we'll touch a little bit on the standards across the world. So as you can see on the table, I actually listed the standard approvals between the region. We have the NIOSH, which is from the US, the FFP, which is from Europe, the N95, which is from China, P2 from Australia, and also Korea and Japan. Filtering face respirator, FFP, so are subjected to various regulatory standards across the world. These standards specify certain required physical properties and performance characteristics in order for respirators to claim compliance with the particular standards. Especially during certain situations like pandemic or emergency, health authorities across the world often refer to these standards when making respirator recommendations. Saving, for example, the current situation, WHO do recommend on either N95 or FFP2 similar respirators. What we show over here on this table are only intended to help clarify some key similarities between such references specific to the FFP performance. So as shown in this summary table, respirators certified are meeting these standards can be expected to function very similarly to one another based on the performance requirements stated in the standards and confirmed during conformity testing. One important note to note is the comparison between the flow rates specified by these standards for both inhalation, which we mentioned over here. This is actually the inhalation flow rate, and also exhalation flow rate. So the inhalation flow rate itself, which over you see on the slide, the test flow range between 40 to 160 liters per minute, while the exhalation might test differently, and some countries will be required to test to be performed at multiple flow rates. Some countries will only require to test at the high or low range, low end of these ranges. So, although this appears to suggest that the standards requirement for breathing resistance, which is also known as the pressure drop, differs from each other, it's important to understand that pressure drop across any filter will naturally be higher at higher flow rates and lower at lower flow rates. Given the typical pressure curve for respirators, the standards various pressure drops requirement are actually pretty much similar. If one filter is tested at a high flow rate, the pressure drop performance will be relatively high, while the same filter is tested at a lower flow rate, the pressure drop performance will be relatively low. So actually, if you really take into consideration, we look at over through the various testing agents itself as the first part. So the agent tested for NIOSH N95, we are only tested on the sodium chloride as a testing agent. But if you look into the rest of the approvals like FFP2 and also Korean first class, not just sodium chloride will be testing as well for the paraffin oil. So that means what it really means is that oil mist or actually oil-based particles can actually affect and degrade the filters over the time. So for filters to maintain its maximum efficiency itself, we need to test through the oil base to ensure all different types of particles are actually being filtered and does not disintegrate the filter capabilities. Next, we'll touch on the inhalation flow rate. The testing might be different, 85 liters per minute for NIOSH N95, while FFP2 we are testing at a slightly higher flow rate. And we also do measures in FFP2, the EN standards, on the total inward leakage. That means based on the calculation aromatic mean itself, you see what is the leakage when the air is actually being breathed through the filters itself. But however, this is not being tested in NIOSH, notwithstanding that this is which is better, but just that we do additional testing under the EN standards itself. And the measuring for inhaled resistance are slightly differs between NIOSH N95 and FFP2. Depending on the flow rate, NIOSH tends to usually measure at the lowest and the highest point, but for European, we actually not just the lowest and highest, but we also measure in terms of clogging. That means in very extreme situation where there is double the times of normal concentration of dust that actually clogs up the breathing, the filters, do they still actually perform normally, and to what extent that it's actually totally stopped at pressure level. So for acceleration resistance, one of the key things that usually I recommend to the customers is looking at the clearance of the CO2. As you can see just now from the basic principle of breathing, we're breathing normal air, there's a dispersed out of CO2 from the combustion of the O2. So if the mask is actually, I would say, have a strong breathing resistance towards exhalation, there might be a buildup of carbon dioxide in the face mask itself that actually causes a lot of discomfort and actually increase the inside temperature of the mask. So this has to be one of the considerations that you might want to take into it in terms of comfort, end of the day, for all the employees. So I'll touch on a little bit more deep dive into both EN and NIOSH differences. So for EN 149, which is the actual standards that is used for European, they differ the class into class 1, 2, and 3. So for class 1, it's actually on low efficiency. For class 2, it's actually on the medium efficiency, which is very much close to the N95. While for the class 3, it's actually 99.95%. So it is designed to be used for both solid and non-volatile liquid particles, which inclusive of oil-based means, and some of the products that might go through additional testing, which is called clogging or dolomite testing. So products are the performance tests which include in this test is actually including the filter penetration, the extended exposure test, the breathing resistance, the total inward leakage, which I mentioned just now, which evaluate the filter penetration, the valve leakages, if there's any valve, and the most important, the phase seal leakage of the respirator. So this is being taken into consideration compared to N95 or NIOSH standards. This is not really being tested. And for certain models of masks, we do have what we call clogging or dolomite dust test, which is testing on the clogging resistance. This evaluates the ability of the respirator to continue to function effectively and provide respiratory protection at a very, very high level of gas environment. This is optional, but for some of our models, we are available with this dolomite testing. Next, we touch on a little bit on the NIOSH. So NIOSH is actually classified into N, R, and P, and 3 different classes, 95, 99, and 100. As you can see from the presentation over here, 95 is the lowest, which is actually close to the FFP2 at the 95% efficiency. Class 99 is at 99, while the 100 is the maximum, which is like similar to the FFP3 at 99.97. In addition, they have 3 different classes, which is called N, R, and P. N is actually non-resistant to oil. That means protection against solid and non-oil-based liquid particles. There is another model, which is the R, which is additionally against oil-based particles for a limited time. And last is actually P, which actually extended use of the respirators that's more than 8 hours. So, notwithstanding both EN and NIOSH, I just want to highlight for all disposable respirators, it's all designed to be used under one work shift, which is actually 8 hours, except for P rated, which is more than 8 hours. Okay. But of course, other than we just talk about the different standards and the different percentage of total efficiency, what is also need to make known to you guys is actually the different particle size and how it actually works. So when we look at N95 or even FFP2 at the 94 to 95% efficiency, it is focusing on what we call 0.3 micron, somewhere around here, which is usually at the baseline of the microns. So why it is being focused at 0.3 microns is that it is the most penetrating particle size. These particles of this size, that's 0.3 and above, always move in ways that we could anticipate. Example, from different angles, and it will be trapped in the filter with gas smaller than this particle size. Particles smaller than 0.3 microns, which is what we call a virus over here, or large molecules, they will actually move in a motion of what we call as a Brownian motion, which is a phenomenon whereby the particle mass is small enough that it no longer travels unimpeded through air. Instead, it interacts with the molecules in the air, example like nitrogen and oxygen, that causes it to pinball between them, moving in erratic pattern. So because of this size, the filters might not be able to capture it, and it has to be used another method to actually capture it, which what we call electrostatic ways to actually capture this type of small particles. So what we can take away from this is that the high efficiency, even though the particle size might be smaller, they still be able to filter it because they are moving in this what we call as the Brownian motion effect. So this is actually how it looks like if you actually at a microscopic view of the particles, the FFP filtering phase pieces. So it's actually produced by a small layer of different plastic cells that they are so small that 0.3 micron using based on the FFP2 or N95 will be caught by them in this kind of spaces. So you can see like the background and brown and green. These are actually dust particles that have been, or small particles that have been caught into the net. However, like what I mentioned, they move to the Brownian effect for 0.3 microns and below. These particles are too small to be captured. So the plastic properties of the filtering phase piece will actually help to catch them through electrostatic means. Again, this is it's possible for us to actually catch every different dust particles depending on sizes, but because we are only using the mechanical filtration in the filters. However, considering of all how this is being made itself, we also need to take note. Comfort is also a priority because if you have a very good filtration material, that means it's harder for you to breathe, and inflow of air is actually harder. So we need to optimize the different materials and increase the surface. And also ensure the filter materials have electrostatic charge so that they can catch off smaller particles. I just want to highlight one part is during this particular situation, do not touch the front of the respirator. So most of the respirator with cup modes, you can actually have a small gap between your palm and the respirator. As you can see from the pictures or the presentations, the front of the respirators are through like a net, which catch a lot of filtering particles, including viruses and bacteria when we breathe. The problem is occurs when we touch the front of the mask and then we touch other places, especially like our faces, which then it will transmit the viruses or harmful materials onto us. So just try to avoid to touch the outside of the mask to prevent this type of particles that are being filtered are being actually used as a residue onto your hand. I would also like to touch a little bit on the fluid resistant test. So for all FFP itself, they are designed to be used as industrial use masks. It's not really designed for what we call in the hospital use or actually in pandemic situation. So alongside these regular respirators, there are also respirators which we also classify as surgical or surgically approved respirators. These respirators not just carry the N95 or FFP2 standard, but they also go through another series of additional tests for fluid resistance. So there's two different testing as per what we know of, like NIOSH and EN from US and Europe. So for the US models, some of them will go through the ASTM F1862 to test on the fluid resistance, while for the EN, or which is now called as ISO because of the new combination, it's actually 22609 to test for the fluid resistance. So what is actually fluid resistant? So this is covering the edge cases such as, example, for in surgical environment in the operation room, when artillery is being punctured, high pressure blood is being sprayed directly onto the respirator. So for this test, the mask have to withstand such high velocity test rates to ensure the mask do not actually leak into from the outside to the inside. Some of the masks will be tested at 3 different velocities to the range of the human blood pressure, which is actually 80, 120, and 160 mm. So the inside of the mask will be inspected and tested to see if any syndicating blood has penetrated through the inside of the face mask. Fluid resistant, according to this test method, is when the device passes at any of the 3 different levels is being tested and viewed through. So for pandemic situation for frontline workers, N95 might not be sufficient enough. The mask itself has to be considered with additional fluid resistant tested. So for some of our models, for the EN models, we do have the EN models that test under the EN, like our 17200C. While for some other models, like the NIOSH version, we do have tests under the ASTM F1862. So to ensure this could be used in pandemic situation or situation that require some of the fluid protection against some of the fluid splashes. I'll touch a little bit on the framework itself. So for in ASEAN region, we accept both NIOSH, EN, and Australia as a general. So you could actually use any of these approved masks within the region, whether you're in Thailand, Vietnam, as long as you use a NIOSH N95 or the FFP2 according to your local regulations from the company. Sometimes you are able to use this range of masks. In some extreme cases, we call, like example, Singapore, we have the local standards like SF, Singapore standards. So the Singapore standard actually specify we can actually use both EN, NIOSH, Australia, in additionally Japan or Korea standards. For Malaysia, there will be new standards coming out as we know of, which is the MS standards, which strictly follow the EN. So depending on local regulation, you might need additional local approval for the disposable mask, which is like Malaysia. So I'll touch a little bit on the fit check of the disposable FFP. So most of the time, a lot of my customers come to me, what is a fit test and what is a fit check? So I just want to quickly run through. The fit test is actually an annual test itself, or every time test in case there's a change in terms of facial expressions or in the face itself. You have to run through the fit test to ensure the supply model of the FFP actually fits to your face with no TIL inhalation situation that you might smell of the contaminants. But for fit check, it's actually everyday procedure when you don on the FFP respirator. So you need to double check the fit to ensure the respirator is being pressed and done properly before you went into the contaminated area or work area itself. So for fit check itself, there's two different checks. One is we call the positive fit checks, and one is we call the negative fit checks. The positive fit checks is actually by so-called inflating the FFP. So we actually cover the filtration base, or if there is actually exhalation valve, you will cover the exhalation valve, and you will actually do a blow out from the mask to ensure that no leakage occurs on the face shield itself. For negative pressure check, it's actually when you cover all the filtering and also the exhalation valve and take a deep breath to ensure the respirator is being pulled towards to your mask. So this will consider as a satisfactory fit. However, for fit test you should conduct annually, you have to be go through a tester. The tester will actually don the wearer on the hood itself. Before starting, you actually test, you can be test on the chemical which is actually approved to be tested. You'll be test whether you actually feel the chemical presence. And if you pass it, then after this, you will start rest for 15 minutes. You'll not on your respirator. It has to be your own respirator or the particular model that's been supplied to you to ensure this is the correct size to you. So the fit testing is to ensure the correct model, the correct face size of the respirator is being supplied to the employees. And through them, we will detect any leakages. And if there's leakages or the wearer could actually taste the abnormal smell or abnormal taste itself, we will classify as a fail. They have to change the mask or they have to change the size of the mask to ensure they have the adequate fit. So again, I want to actually break off the myth. A fit test is not for every year. It's supposed to be conducted as per the following rules. If you are a new wearer, if you change the mask model, if there's additional equipment being added. So example, if you are wearing a safety glasses, particular model, and you change a new model of safety glasses, all the employees that change the glasses of the models have to be tested again. And if the employee previously does not wear any glasses, somehow or other he starts to wear safety glasses, he has to be fit tested again with the safety glass. If any of this does not fall between the year, then they have to do it every single year. That's where we say fit test will be conducted every year. But if any of that occurs in between the year itself, they have to be fit tested again. And last, most importantly, the supervisor has to take note if there's any facial changes to the person. So example, over here, he actually slimmed down, or somehow or other he went for some different changes on the facial itself. They have to be fit tested again to ensure that the mask still give a proper fit to the wearer. And during the fit test, the facial hair, the beard, the goatee, and all stuff, they have to be cleanly shaven, so to ensure there's a full fit to the face mask itself. So last but not least, I just want to talk a little bit about the selection and use. So most important, most of the time when we wear the full FFP, we need to really consider some other factors rather than just the protection level which we mentioned. So example, we need to look at the face and the head comfort. The respirator edge itself should be flexible, and the shape and size should cover the nose and the mouth, and also the chin, without causing excessive pressure. The headband material has to be taken note as well. It's supposed to give a good and even tension across the head to ensure a comfortable, secure fit for the range of the head size. You also need to take note about skin comfort. Skin comfort will be affected by the smoothness and the softness of the inner material of the FFP when in contact to the skin, especially when we look at wearing FFP for a long period of time, like 8 hours. So a soft inner face seal and even a sweat-absorbent nose form will provide a greater comfort, while rough or hard materials and coupling with high temperature inside the respirator can cause itchy and unpleasant situation. So when we talk about this, is that sometimes of the filters itself, they might be too well protected, a lot of heat being built up. So with that in mind, you have to actually look into the coolness of wearing the respirator. So you might look into it. Maybe you might want to look into with an efficient exhalation valve to minimize the heat built up inside the mask itself, which you can take advantage of how different manufacturers like Dräger will provide better exhalation valve in terms to remove the excessive air to ensure the coolness and comfort for the employees or wearer. So again, I want to break off another myth is that the FFP are not designed to use with gas and vapors which can pass through the filters easily. You have to use a filter or half mask itself. There are some products in the market that say they are OB protected, but they are actually based on the nuisance level. When you say nuisance level, is your environment has to be within the operation exposure limit range. And these properties of the organic vapors have distinctive smell that actually cause a lot of discomfort. So the OB or the black charcoal layer that outside the disposable FFP is designed to remove this type of nuisance to ensure the workers are working at a, I would say, comfort environment, but they do not remove the organic vapor itself. They just absorb certain parts of it, and it still can actually slip through the respirator. So for concentration environment that's higher than occupation exposure limit, you have to use a half-face respirator instead. So to check on all this detail, you can actually visit our Dräger website where we have a hazmat product finder. You can check on the various substances that could be and the various substances and the operation exposure limit that you can actually based on that to identify your environment. Should you use a disposable mask or actually should you use a respirator mask with filters? We do have more white papers and recommendations in terms of respiratory protection. You can actually visit our science issue website, dräger.com, to actually find more details in terms of respiratory protection. All right, so before I end our presentation, I'd like to show you a new video that we have prepared for our disposable mask, especially on our series and on the current situation, why some of our masks are designed and being tested and how it's being made.
How important is safety to you? For us as a manufacturer, safety means protecting you as best as possible through quality. Therefore, we make no compromises when it comes to materials and processing. In our test laboratories, we test our FFPs against microscopic aerosols and the finest dust particles in the air. So that at any temperature and even long wearing times, you are effectively protected. The perfect fit of our respiratory masks is also no coincidence. It is the result of well thought out product design and continuous innovation. Our quality, your safety. Respiratory protection from Dräger.
Okay, so thank you. That's the presentation for today, and I'm here to actually answer all your questions and answers.
Thank you, Michael, for the presentation. We have now come to the Q&A session. If you have any questions, please type in your question in the question box using the control panel. Michael, I see some questions already. We may start with the first one.
Okay, so we have a question over here. Are we still 0.3 micron or less? Okay, so I'm not sure if I understand your question. If you are looking at the FFP2 or if you are looking at the N95 models, it's typically we are looking at particles that is the from 0.3 microns onwards. Anything that is actually bigger than 0.3 microns. Anything that's lesser than 0.3 microns for N95, there will have a possibility chance to actually go through the particle filters. However, as I mentioned during the presentation, there's what we call a Brownian effect for very small particle size, especially if you look at the viruses that don't actually move in routes that normally be anticipated, such as aerosols, because they are staying in the air itself. So they will actually pinball effect that they are moving across with the different molecules in the air, and this will be captured through electrostatic capabilities of the mask. Okay. Okay, I have another question. Can I reuse my disposable mask? Wow. Okay, this is a hard question. First, all FFP filtering face beads are designed to be used under one worksheet or maximum 8 hours. We don't recommend you to use above that period of time. So you have to actually use within the 8 hours itself. And if you decided to reuse your mask at your own risk, you will need to actually go through a serious way of sanitizing the mask itself. So we don't recommend the reuse is because through the sanitizing of the mask, most of the time you actually go through the washing, or actually you will use the alcohol method, propanol, to actually cleanse out the mask, which both of this method will actually reduce the filter capacity significantly. You will degrade the filtration material, and thus you will actually cause the FFP to be not effectively being used at the right anticipated level itself. So you will be no longer N95 or FFP2 range once you actually go through such kind of sanitizations through alcohol or washing. So it's not really recommended to reuse, and we stick on to the rule you have to use within the 8 hours, which is testing requirements of it. There are certain models that can use above 8 hours, which we call the P models, but that has to take into really consideration that after the use, you need to seal it up in a Ziploc bag and using a clean arms to actually handle all the respirators and to ensure during the storage period it's not being contaminated. Being the FFP itself, this is very difficult to achieve, and so usually I don't recommend it to reuse all your disposable masks. Strictly follow the 1-time worksheet or the 8 hours worksheet. Okay, so other questions we have is like, which is better, N95 mask with valve or without mask? Okay, so the design of the exhalation valve for N95 mask is to ensure all warm air built up inside the mask is being dispersed out. So it gives a better comfort, especially if you are working with long duration, you're looking at 4 hours, 6 hours of working time. With exhalation valve, it will reduce the discomfort in the mask and reduce the number of CO2 that's built up in the mask so that you won't feel so warm. You won't be sweating inside the mask. Another concern is that because the heat is being built up without the exhalation valve, you'll be sweating inside the mask. And when fluid touches the woven materials, it might cause a degradation of the filter materials, because of the water seeping. So it reduces the filter capacity. So usually I look at the duration if you are working or wearing the mask. If you are wearing for a long period of time, we recommend it with a valve. Most of the valve is actually designed as a one-way valve. So if you are using the valve mask correctly as 8 hours or one-time use, you will be pretty much very safe, because the one-way valve will prevent all particles go through the valve as well. So yes, another question mentioning some other models in the market offer low level of OV and low level acid gases. Okay, again, I reiterate this question. The low level is actually used in the permissive level of occupational exposure limit. So example, if you have organic papers that is under the OEL, it's no difference as no wearing mask. It's just that the OV protection itself is to remove the nuisance level of the warning properties of the mask. So example, you are working with a spray can that has alcohol content itself, that you might smell some of the alcohol that's really pungent to your nose. The OV layer will remove that nuisance level. That's the main features of it. If you are working above the OEL, you will still have to use a half mask with respirators, half respirator with filters. So we do offer the OV models, which comes with a black layer charcoal in front. Yeah. Okay, so another question I have here. So what makes the difference? A material used as a filter or anything? Okay, a lot of things you mentioned makes a lot of difference. Of course, if you look at the whole disposable mask itself, especially I mentioned during the just now, the selection. Okay, the protection level is a bare minimum. You have to beat the protection level. If you know that you have to use an N95, it will be an N95, which you can use an FFP2 instead as well, but the protection level will be the same. But you need to also look at your contaminants in the area. So a lot of times, a lot of customers that actually miss out is the mist or the working. Example, you are grinding or if you are drilling, you do actually use some additional chemicals such as cooling oil or coolants to actually cool down during the drilling through the metals. These products, when mixtures with or the dust itself, is what we call as oil-based particles. So these products or chemicals, they do affect and degrade the mask over time very quickly. That's why if you can't use an N95 by using this product, you will have to use an R95 or an FFP2. So generally, the FFP2 will be covered for both oil-based and non-oil-based particles, but not for the N95. So this has to take into consideration. Another real consideration is you need to understand, most importantly, is the comfort of the wearer itself. So not just the filter material, the inside of the face mask, how it's been laid onto the wearer's face itself. Is it soft enough? Is there any additional support? And how is the face shield providing to the wearer? Is it giving a full seal, or is there any potential leakage to the mask? So these are some of the considerations that you need to take into consider when you wear into a disposable mask. And these materials do make a difference for a long-time user. So if you're a long-time wearer, you have a material that is very hard, and you can actually cause cuts onto your face, and it's very uncomfortable. And you don on the mask again, you actually feel the pain, and it affects your productivity. And the inner filter materials, it does make a difference as well. So back to your question, yes, all products, all material makes a difference, because the material that's been used as the material designed or choose to use as a filter material has to be also both electrostatically charged. That means, we mentioned filter materials at 0.3 microns are for dust particles, but those lower in size also need to be captured as well. So with that itself, they have to be captured through electrostatically charged filter material. This plastic filter material has to be able to obtain their brown capture this particle through their browning effect and stuck onto their the net itself. So yes, the filtration material does matter as well. Okay. So is there any testing that light ion can disinfect the mask without changing the mask filter? Okay. So this is a very interesting question. Light ion or actually UV light, yes, at adequate dosage, it might provide sanitization effect. However, there is no actual testing being tested and official being released out that say that using the UV light or light ion that it can disinfect the mask without changing the filter capabilities. So I would say that there is not that I know of at this current moment of time that this can be safely used to disinfect the mask without degrading the filter materials. Of course, if there's a shortage, then it will be a different scenario issues. But we will suggest that there's no testing and there's no approval testing onto this. We do not recommend you to use UV light or ionized light to actually sanitize the mask and reuse it over again. A disposable mask, as mentioned, disposal has to use within 1 work shift or 8 hours. Okay. Is there any tools to calculate how long a filter can last for disposable mask? Okay, so if we are talking about disposable mask, no, there's no calculation. You will be only used based on the 8 hours or 1 work shift maximum range, whichever comes first. So that means it's either 1 work shift or 8 hours, whichever comes first for disposable mask. That's the strict and basic rules. As for reusable filters, this has been discussed during the last webinar sessions. There is a requirement from the NIOSH requirement that you can do on the calculation, but again, that is on the very hypothesis calculation. So in a very resting mode of a human, we take in around 8 to 12 liters of air per minute. Working wise, maybe up to 20 liters or 30 liters. So for us to do a pre-calculation how long the service lasts itself, we have to take into the breathing intake of every individual person. And do remember, humans breathe differently. Some people might take in more heavier breath, some people might take in lesser breath. So it's very difficult for us to gauge on the inhalation of individual person. Secondly, the environment of the working environment. So you need to take into consideration what is the concentration of your gases and to do the calculation. And this concentration has to go through another lab test. Then followed by the capacity of the filters itself, followed by the environment temperature, which will affect the active carbon inside the filter, which also including the humidity of the area. Different countries have different humidity, and some countries have various humidity level. You can't take the average out to base as a very minimum base. For example, some countries will range between 40% humidity to up to 80% in a very single area. So that can cause a huge difference in view of the service life of the filters. So with all these different considerations itself, for the EM-based filters, it will be still under the user knowledge of, in terms of there's more breathing resistance, they change the filter, or they start to smell the volume properties of the gases, they need to change the filters. Okay. Another question. Can we wash the N95 mask? Nope. You can't wash the N95 mask as mentioned. The water will actually degrade the filter capabilities and it will be a danger and cause to it. So N95 masks or even FFP2 masks are not designed to be washed. Okay. Oh, another question. Oh, so there's this question asks, okay, how should I put it? This question asks, how the respirator protecting us in times of pandemic? Okay. Okay, so basically, let's take example, when the user cough or sneeze, there will be droplets in the air. So droplets is the primary reason for wearing a respirator, to actually protect yourself, the wearer, against these droplets. So example, if the sick person cough or sneeze in a very close proximity, the respirator forms a barrier which prevents the bodily fluids to actually reach our face. Droplets are generally large and gravity will drag them down to land on the object rather than stay on the air. However, so that because they are so large, they don't travel at a very long distance. However, there will be also micro droplets as well. So when we talk about micro droplets, which could be ejected during cough, normal talking, this we do not know. We know that large droplets plays a very big role in transmission, but it's not very clear in terms what type of role these micro droplets do really play. So these micro droplets may remain in the air for some time and are aerosols virus particles. So in view of that, there could be such a very micro droplets or micro bacteria in the air or viruses. You will need to use a good enough filtering face piece to protect yourself, because the normal mask will not actually protect you due to there's not actually face shield enough. Okay, so what is the main difference between N95 and KN95? Okay, so let me go back to if you don't mind, let me just go back to the table itself again. So let's look at this table. For both N95 and KN95, and KN95, they do have a total inward leakage test, which actually it means that they test in terms of the face shield, they test in terms of from the air coming in, is there any leakage from the sides? But this is not tested in, or not required to be tested in the N95. Then of course the inhalation resistance is on a higher pressure to ensure a better protection for KN95 compared to the N95. And of course, the acceleration testing are different. And they also additionally for KN95, they tested for the clearance of CO2, which to ensure that no more than 1% of CO2 is being put up inside the mask to ensure the comfort of the user at all times. And most of the time, sorry, not all times. So that is the key differences between KN95 and N95. Yep. But in view of the rest of the general properties, both are pretty much similar in terms of testing. It's whether, another question to pose is whether the local authorities or the local regulators do allow KN95 to be used, because it's a different country standards, but though the testing properties generally about the same, it's the local authorities whether do they feel that it's sufficient for the locals, or they will accept, not sufficient, but will they accept the KN95 model, or they will still enforce just the NIOSH or EN model. So for our region, if you are using the EN or NIOSH model, you are generally still under the local approved authorities. Okay, last question, I'll pick it up. Okay. So do we know the average concentration of particle in the, if we know the average concentration of particle in the environment, can we determine the exact shelf life of the reusable mask? Okay, so this is pertaining to the half mask. Yes and no, because I mentioned just now, we need to know the inhalation, average inhalation of different wearers, which is very difficult. The temperature and humidity, these three are the causes of the various situation on the service life. We can judge on the rough estimation service life based on your concentration in the environment and the temperature, humidity, that is only based on the graph gauge. So do contact Dräger representative and you will have a more in-depth discussion on that. But other than that, there is no, I would say there's no correct way to calculate before use how long the mask can, how long is the service life of the mask, because again, it depends on the wearer, it depends on the environment, it depends on the temperature and humidity around the environment as well. So it's not just on the concentration, but also environment and wearer, which is the hardest way to measure in terms of reality. So we can give a rough gauge, but not the very close estimation. Okay, so thank you for your questions. I might not answer all the questions at this moment. So we will consider your questions and we will actually reply your question one by one. And then we will actually sort in the email and send it back to you.